This lesson is 7.2b, and today we're going to be working on expanding quadratics. In this warm-up, most of this you should be able to do yourself, but let's just go through it briefly. Number one is asking for what form are all these quadratic equations in. So if you, again, remember the forms are on the last page. They're right here. All right, so you need to kind of look at those forms. Most of them are pretty close to that form. There's a couple on this warm-up where they're kind of written in a way that makes you have to think a little bit as to what form that really is. But you can go ahead and do those. Number two, you should be able to do as well. Given the parabola, find its vertex. We learned how to do that yesterday. Because this equation is given in standard form, you should be able to write it, find the vertex, and then write it in vertex form. It also says sketch it without using technology. So when you make this table, right, remember whatever you find for the vertex, that should go right there. And then you, for the x values, you can go down and then up with little arrows from that spot. That's kind of how to center your parabola so you get a good point. I will say the vertex isn't a great number, so that might take a little bit of work on your part. You can always take this and put it in your calculator or Desmos and find some points too. But again, it did ask you to do it manually, so try to do it that way first and maybe check on your calculator. All right, so that's it. So go ahead and do that. Okay, let's go through these. In terms of number one here, take a look at your answers. Probably the trickier ones were E and F. E, I would say this is probably factored form, but you could call this vertex form too. If you added one thing to this, like a +0, then that would be vertex form. With the x minus 2 squared, you could write this as y equals negative and then x minus 2 times x minus 2, like that, and then that would be factored form. So that one's kind of tricky. It's definitely not standard form. And then F, if you bring this 8 here over to the end, then that looks like vertex form. So those are a little tricky. To number two here, given the parabola, find its vertex and write the equation in vertex form. So to get something to be in vertex form, we need to find h, and we use this equation that we learned yesterday. You get 3.5. So make sure you're getting that part right and applying that equation correctly. Once you have h, which is 3.5, you can plug it back into the equation for x. And that, I don't know why, but that's a step that students kind of get stuck on. They don't know how to find that k value. You're just taking the h value, which is the x value of the vertex, and plugging it in to the equation to find out k, which is the y value or the y coordinate of the vertex. And so that is what you should have for the vertex. And then once you have the vertex, you can write in vertex form. The a value stays the same. Oops, you know what? I didn't write that correctly. I just kind of copy the thing. Let's do it now. We'll just do it together. It's y equals, let's change my color here, y equals, and then -2 is the vertical stretch, x minus 3.5 squared plus 5, like that. So then that should be your equation for in vertex form. If you graph that equation and you graph the original equation like on Desmos quickly, you would only see one parabola. In terms of manually graphing it, I put 3.5, comma 5 in the middle, and then I just went up. I actually went up the first one by just 0.5 so that I could have integers in that x column. I didn't really want to have decimals, and then I kind of found the other problems. Again, that one's probably not the best one to ask you to do manually because there were decimals in it, and that's kind of hard. All right, so today we're going to talk about expanding quadratics from factor form to general form, as well as expanding vertex form to standard form. And so this should be review for you. You did this. If you're a 9th grader right now, you did this in 7th grade. If you're a 10th grader right now, you did this in your geometry class. That first quarter, you spent time doing algebra stuff, and this was one of the things that you learned. So again, it should feel like review, everything else that we do in this lesson today. So expanding, there's two ways to do it. There's the sneaky square / factor boxes, okay? Teachers call it different things. Or there's the FOIL method. I think you should be able to know how to do both things, okay? Because FOIL method's a little bit more, it doesn't take up as much space in your paper, it's less work, but the sneaky square factor box method is helpful for factoring, and it also, it's just a nice pictorial of what you're really doing, okay? They both do the same thing. So if I want to use factor boxes, I'm going to put these two factors, x minus 5 and x plus 2, on these sides. It doesn't matter which one you do where. However, if this one, this plus 2, if that's a negative, sometimes students do things like this. Let's say that was, let me just switch this so that I can show you what I'm talking about. Because I see the errors, right? I know what students do that makes mistakes. So if the x plus 2, sometimes they'll do this, x minus 5, like that. And when they do that, when students do that, they almost always forget to apply the negative with the 5 when they're multiplying out. So don't put it there. If you're going to write, if you have a minus term there, put the minus in front of the 5 like that so that you don't forget that that was a minus. Okay, now we multiply all these things. So like the first one, x times x is x squared. 2 times x is 2x. Negative 5 times x is negative 5x. And then negative 5 times 2 is negative 10. I do that, and now I just kind of clean this up. So you can combine like terms, and the like terms are always going to be these guys here when we're doing quadratics. And so negative 5x plus 2x is negative 3x. So now I can write this as x squared minus 3x minus 10. All right. FOIL method this is the way I learned how to do it back in the day. It means it's an acronym: first, outer, inner, last. And sometimes students, even after I say that, they're not sure what these things are. So let's just go through it. The first terms are these two terms, the first terms of each factor. And then the outer terms are going to be the ones on the far outside. So this x and this 2. And then the inner terms are the ones on the inside, right? So that's going to be this guy with the negative included and that guy. And then the last terms are the last terms in the factors. So I think that's why that can be confusing. So like negative 5 and the 2. So when you multiply those out, you basically multiply each of those things, and then you add them all together. It's the same thing as factor boxes, right? Factor boxes do the exact same thing. You're multiplying all those different pieces. So when I do the first, it's x times x, x squared, plus, and then I do the outer, which is x times 2, which is 2x, plus the inner ones, negative 5 and x, so negative 5x. I didn't need that plus sign there, but that's fine. Last terms, negative 5 again, and 2, and that is going to be negative 10. And then you have like terms there, the 2x and the negative 5x, so you add them, x squared minus 3x minus 10. You get the same thing as you did if you would have done it the long way, or the sneaky square / factor box way. Okay, so knowing that, I think that you can go ahead and do A on your own. And I do want you to try to do it both ways, right? Because that's kind of the practice you need. And then we'll do B together. B slightly different because the coefficients in front of the values of x are not 1. So go ahead and do those. Either way, you should have gotten x squared plus 1x minus 12. Note that you do not need the 1 in front of the x there. So if you had this one that I have right here, you don't necessarily need that one. So I wrote it without it. That's kind of redundant to say that, but it's fine if that kind of helps keep it straight what's going on. All right. B, let's do together. We said we would do that one together. So if I have 3x, and again, it doesn't matter which one you put on which side, but here again, put the negative in front of the 5 as you do that. Now, when I multiply, this is where students kind of go wrong here. 3x times 2x is 6x squared. The top left one for quadratics is always the squared term, unless they really start scrambling things around. And then 2x times -1, -2x. 3x times 5, -15x, and then -5 times -1 is 5. So I get, with factor boxes, 6x squared, and -15 plus -2 is -17x plus 5. If I FOIL this, we do first, so that's 6x squared. Outer, 3x times -5, -15x. Inner, -1 times 2x minus 2x. Last is the -1 and the -5. I got a little delay on my Screencastify right now. All right, so then you add these all together, you get the same thing, 6x squared minus 17x plus 5. When you get to South, you're going to see your teachers there. I mean, they're usually going to FOIL. They are not going to be using the factor boxes or the sneaky squares, but you can do whatever you want, okay? Whatever makes the most sense to you. Okay, so the next one says converting from factored form to standard form. So now what we're going to start doing is taking things that are in factored form and changing them to standard form. We're going to do all the different ways, moving vertex to this and that and factored form to whatever. I mean, we're going to do all of it. So that's what this kind of section's about. So I'm going to show you a couple different ways to do this. So the first way, if you like the factor boxes, you can do it like this. I'm going to say y equals, and put this negative here. Put this giant parenthesis here, okay? Because in the parenthesis, I'm going to put a box, which I kind of justify to the right so that it's over on the right side, like that. The negative right there, that a value, I mean, if that's like on the next problem, that's 0.5, that goes on the outside of the parenthesis. And then I'm going to write my two factors like this. So this is a very nice, it's just a nice pictorial way to do it. And I'll show you with FOIL as well. But if you like doing it this way, it looks kind of cool. All right, so now I'm going to multiply on the inside. And so I get x squared and minus 7x and -4x and 28, like that. So now my next step, I will write this as y equals negative. I kind of keep, that's my negative from outside the parentheses. And then inside my parentheses, I'm going to write my like terms. So x squared minus 11x plus 28, like that. It's 11 there. And then my last step is to distribute that a. So that negative or -1, you can think of it as a -1, is going to be distributed, and it's going to change all the signs. So it's going to be -x squared, or you can say -1x squared if you want to, plus 11x minus 28. Okay. The next one then, I feel like we can do that. You can kind of do this when we kind of do it in steps. So let's start with, actually, you know what? I want to do this one with FOIL, so you're not going to do this one. I'll have you answer some questions at the end. If you're doing it with FOIL, then I kind of go like this. I might need to make that parenthesis a little further away. So I put the 0.5 out there, and I'm going to multiply all this out first. It's possible that another way to do this problem, but I don't recommend it, is students will distribute the 0.5. You could distribute the 0.5 to both these things, but not to all of the things. If you're going to multiply 0.5, it's being multiplied, like if you have 3 times 2 times 4, you don't multiply 3 times the 2 and multiply 3 times the 4 and then multiply those two things together. You'd only do like, well, I do this first. That's 6, right? Multiply the first two things together and then take that answer, 6, and multiply it to the 4. So again, when you think of it here, like you can't do 0.5 times the x and the -2. That would be like multiplying 3 times 2. And then I'll also take that 0.5 and start multiplying it to the next thing, then you're multiplying by 0.5 like doubly, right? And that's not, I don't think doubly is a word, but it would be overdoing it, okay? So make sure that if you do decide, oh, I'm going to multiply the 0.5 out first, you only do that to one factor. And again, that's not how we typically do it. So I would, because then you end up having a more complicated factor. And like these factors, x minus 2 and x minus 9 are kind of simple. Let's use FOIL. So we're going to use FOIL on this stuff right here. First term, x squared. Outer term, negative 9x. That's this x times this negative 9. Inner term is the negative 2 times the x. Last term, negative 2 times negative 9 is plus 18. And then my last, oh, actually, not last step, I'm going to combine like terms. So this negative 9x and the negative 2x I'm going to bring together. That's going to be negative 11x. And then I am now, my last step is going to be just to distribute the 0.5 to the things that are in the parentheses. Y equals 0.5 x squared minus 11 times 0.5 is 5.5. So negative 5.5x. 0.5 times 18, that's half of 18, is 9 minus 9. Double checking my answers there. I have a mistake right here. This should have been a plus. I think my pen, can I blame it on my pen? I think I will. My pen wasn't working very well. So that should be plus 9. All right. Down here, state the vertical stretches for examples 2a and b. This is something I think you can do on your own. So go ahead and do that. So the vertical stretch is the first one. The a value is negative 1, right? Technically, the stretch is 1. I mean, there is no stretch. Or you could say there's no stretch. The negative was a flip over the x-axis, so that's kind of a trick question there. And then for b, it's actually a vertical shrink of 0.5. The a value is 0.5. The first one would be an upside down parabola because of the negative, and b would be a right side up parabola. All right, we're making our way. Now, the other thing we're going to learn today is converting from vertex form to standard form. So this is almost like going from factor form to standard form. We're going to be expanding just like we were doing before, okay? But now we just have to, there's one extra step with these guys. So it says basically write the squared term as two factors and expand it, then distribute the a, and then simplify the constants. The difference really with these that adds the step is that you have to do that plus 10 thing. You do that at the very end. So I'm going to write this one out. This one I will do with boxes again. Y equals 2. Now the x plus 6 squared, that's like x plus 6 times x plus 6, right? So you are going to have to expand that. Lots of kids like to say that's x squared plus 36, but it's not, because when you expand it, you get a middle term, which you'll see here in a second. So I'm going to make a giant parenthesis. Dog is scratching my leg and wants attention. Plus 1. Hi. Here she is. Good morning. She's helping me do my Algebra 2 videos. Okay, so I'm going to put x plus 6, x plus 6. Now I'm going to multiply this out. So I get x squared, 6x, 6x, 36, like that. Now I'm going to write this all out, and I'll combine the 6x plus 6x as I go. So y equals 2, parenthesis, x squared plus 12x. See, there's that middle term. It's not x squared plus 36. There's a middle term when you have two factors like that, plus 10. Right now, some students are going to add the 36 plus the 10, or they're going to distribute the 2 to everything, including the 10. The next step is for you to distribute that 2, but you don't distribute it to the 10. You're going to distribute it to the things that are in the parentheses. So that's 2x squared plus 24x plus 72, that's a big number, and then plus 10. Y equals 2x squared plus 24x, and that's a 24x plus 82. Okay, I'm going to ask you then, you can write that equation nicely in the next thing. Now you should be able to find the vertex. The vertex was given to you at the beginning of this problem, because in the beginning of the problem, this was example 3 was in vertex form. So you should be able to say that. You should also go back and kind of use your chapter 4 skills and tell me what happened to it. Like, did it go left or right? Did it go up, down? Was it vertical stretch? You should be able to answer those questions too. So go ahead and do that. Okay, take a look at the answer there. This vertex should be negative 6, 10. Again, I'm just getting that from this original equation here, that it went left 6 and up 10. And then the transformation is left 6. Write that one first, the thing closest to x. And then the next operation would be the vertical stretch of 2. And then it went up 10, lastly. Okay, last one, and then we're going to be done with this. I want to write this in standard form. So this one I'll do not with sneaky squares. I'll do it with FOIL. So y equals negative 3. And then I'm going to FOIL that inside, and then I'm going to have the minus 11. So basically, when you're FOILing, it's x minus 2 times x minus 2. Sometimes it might be good to write that piece too. Maybe I will. I'll go like this. X minus 2. X minus 2. So it's all sort of laid out there for you. There will be the kid that says x minus 2 squared is x squared plus 4, and it's not. Okay, there is middle terms here, and so that is something you want to walk away from Algebra 2 not doing anymore if you fell for that in the past. Okay, so I'm going to FOIL this middle stuff, this stuff right here, and I'm going to get x times x, that's the first term, x squared. Outer term, negative 2, or x times negative 2, so that's negative 2x. Inner term's the same, negative 2x. My last term, negative 2 times negative 2, is plus 4, and my parenthesis, minus 11. Now I'm going to combine like terms inside those parentheses. So I get x squared minus 4x plus 4 minus 11. That's. And now I'm ready to distribute my negative 3 only to the things in the parentheses. So negative 3x squared plus 12x minus 12 minus 11. And I'll write my equation down here. Y equals negative 3x squared plus 12x minus 33. Oops, that's not 33. It's 23. Haha. Minus 23. Okay, the vertex and the transformations you should be able to do on your own. All right, take a look at your answers. The vertex should be 2, negative 11. And then it means it went right to vertical stretch of 3, flipped over the x-axis, and down 11. So actually 4 different things. All right, that's this lesson.